Hi, begin with the traveler that inspires this story. Astronomers call it 3-Eye Atlas. The letters mark it as the third confirmed interstellar visitor ever noticed by human eyes, and the word atlas honors the survey system that first called attention to its motion. Imagine a speck gliding across the digital exposures of a wide-field camera. Night to night, the speck traces a path that refuses to close into a loop. That is the signature of a body that is not bound to our sun. The curve is a hyperbola, a single open swoop that carries the traveler inward for one season and then sends it back toward the quiet between stars. Around the nucleus, sunlight stirs a soft veil called a coma and a pale tail that aligns with the solar wind. Most of all, the object feels like a page torn from another world's book of beginnings. Whether it holds water ice or the more ghostly ices of carbon dioxide and carbon monoxide, it is a sample from a kitchen that baked planets under a different star. Now turn the page back many years. A summer night in the late 1970s, a radio telescope in Ohio that students affectionately called Big Ear listened to the sky as Earth turned. The instrument was not a dish, but a pair of long mirrors made of metal mesh with a receiving system that stared straight ahead while the planet rotated the heavens through its gaze. As the sky drifted, any one point would remain in the beam for about a minute and a bit more. On the night in question, the receivers were tuned to a frequency close to the famous hydrogen line, the natural radio note of neutral hydrogen at 1420.4 MHz. This tone sits in a serene part of the spectrum where the galaxy hums softly. For listeners who hope for a deliberate signal from a distant intelligence, that hydrogen note is like a shared landmark. It is the obvious place to whisper hello. The data were not colorful images. They were columns of numbers printed by a dot matrix machine on long paper. Each symbol stood for the strength of the signal in a short slice of time. Zeros and ones marked quiet. Larger numbers marked mild activity. Above 9, the printer used letters A and then B and onward, each letter stepping up in intensity. On one page, a sequence leapt from the background and arched like a bridge. 6, then E, then Q, then U, then J, then 5. The sequence lasted exactly as long as a single point would sit in the beam. It rose and fell with a shape that matched the familiar response of the instrument as the sky drifted by. The volunteer who reviewed the paper later circled the sequence and wrote a single word in the margin. Wow, the name stayed. It is not academic, but it captures the human moment. In calm language, we can say there was a narrowband signal near the hydrogen line, strong and brief, precisely the length that the instrument would see if a steady source drifted through the beam by the rotation of Earth, and never heard again despite many returns to that same patch of sky. Where exactly was that patch? The arrow points to Sagittarius in the deep star fields toward the center of our Milky Way. Astronomers sometimes use an informal teapot shape to find their way in that constellation. A simple outline of bright stars with a spout and a handle. The region of the wow signal lies near the rich star clouds, where the band of the galaxy thickens and where radio sources crowd together. It is a busy part of the sky, a crossroads of natural transmitters. Hydrogen clouds whisper their faint tone there. Pulsars tick in the background with clock-like precision. The galactic center, though still several degrees away, adds a gentle thrum. In such a place, a faint man-made satellite reflection would be quickly lost. Yet the signal did not behave like a satellite and did not repeat like a pulsar. It was a single, elegant arch matching the beam shape, and then silence. That singularity is part of the mystery. It looked like a great candidate. It behaved like a steady source that the instrument happened to scan once, and then it never returned. To understand why that one arch of letters became legend, it helps to feel the rhythm of the telescope itself. Big Ear, built by Ohio State University, was a fixed instrument. Instead of swiveling to aim, it let the sky do the work, a method called drift scanning. 2 feed horns sat side by side so that the same patch of sky would pass through one beam and then, after a short delay, through the other. In principle, a real celestial source should appear in both beams, separated by the known time offset. The wow sequence appeared only in one. That detail has fed both skepticism and speculation in equal measure. Perhaps the signal was a transient that turned on and off at just the right times. Perhaps the second beam was affected by small differences in gain. Perhaps the source sat in a strip of sky where one beam was a touch more sensitive for that frequency. The person who circled those letters considered these options in the calm light of later years. He never declared the event a message from intelligence. He kept it in the space between. It was a strong candidate. It was not identified. It did not return. On paper, the arch of letters looks almost playful, but the scale behind it is careful. The intensity codes climb from 1 through 9 and then A through Z, with Z marking the upper end of the calibrated range. The peak of the wow sequence was the letter U, a high value, but not the ceiling. The total duration was about 72 seconds, give or take a few seconds, exactly what you would expect for the time an unresolved source takes to cross the instrument's beam at that declination, given Earth's rotation. The frequency was close to the hydrogen line, a favorite for those who imagine natural civilizations choosing a universal hailing frequency. The bandwidth was narrow, narrower than most natural phenomena. Many boxes that you would want to see checked were checked. Many others remained blank. There was no precise direction beyond the broad beam width. There was no repetition the next night or the next year. An effort to compare the time of night with the schedule of any earthly transmissions turned up nothing useful. The pages went into a drawer, and students in later years unrolled them like a scroll from a patient archive. From the summer of 1977, we step forward into the era of all sky surveys. The Atlas system, whose name honors a god who holds up the sky, does not hold the sky, but it does scan it with relentless discipline. The goal of the network is practical. It is to find small moving bodies that might approach Earth. The method is to compare wide field images taken night after night to spot any point of light that shifts against the fixed background stars. Software marks candidates. Human eyes review the trails. When an object moves with a speed and direction that do not match known asteroids or comets, the system triggers follow-up observations. In such a cadence, an interstellar interloper stands out by the shape of its calculated orbit. When astronomers fit the positions and velocities to a conic section, the fitted curve does not close like a circle or an ellipse. It opens like a hyperbola. The energy is higher than a bound path allows. The body has arrived from the deep and will return to the deep, forever unbound. 3. Atlas follows such an open path. As it approached the inner system, its brightness began to increase. Images with long exposures revealed a delicate tail pointing away from the sun, the classic sign that sunlight is lifting dust from an icy surface, and that the solar wind is shaping that dust into a curve. Spectra pried from the faint light suggested the presence of common comet gases such as water and carbon dioxide, though the precise ratios are patient to reveal. In this way, image by image, the body confirmed what physics would suggest. It is not a machine, it is not a sail, it is a piece of ice and dust and rock from another system, behaving as comets do when they wander near a star. Now draw a gentle thread between the two tails. The famous wow sequence pointed toward Sagittarius. The interstellar comet arrived from a direction near that constellation. The human mind is built to notice patterns, and pattern seeking is one of our creative strengths. It is also a source of shortcut errors. The sky is wide. The Archer spans a rich part of the galactic plane. Many things happen there. Radio telescopes listen there often because the hydrogen line hums in that direction, and because the time on target yields more discoveries per hour than for a quiet, empty field. Surveys discover moving bodies there often because the background stars give better astrometric anchors, and because geometry sometimes places inbound objects against that backdrop. All of this is a long way of saying that coincidence is not as rare as it feels when two events share a label like Sagittarius. The honest way to hold the coincidence is to leave it open. It might be nothing but a shared address on a crowded street. It might be a prompt to look carefully and to tell the story in a way that honors both wonder and caution. Return for a moment to the column of letters and numbers that made the word wow appear in the margin. How did that line of ink become legend? The details are as human as they are technical. In an age before instant screenshots, the data lived on paper. A person reviewed the paper by hand. When the curve rose in a perfect arch, precisely the shape expected for a source fixed on the celestial sphere as the beam passed over it, the reviewer couldn't help but express surprise. The handwriting made the moment personal. Later retellings gave the moment a title. The single word turned into a name. The name spread faster than the measured facts. That is a pattern we must always acknowledge. Titles arrive quickly. Understanding takes longer. What happened after the arch faded is just as important. The team returned to the same region many times over the following months and years. The instrument by then was matched by others, and they also listened. No repetition was found at that frequency with that beam. Other candidate events have been logged by other instruments in other decades, some intriguing, most resolved into mundane explanations, a few still floating in the in-between. The lesson is also the method. You keep listening. You refine the gears and you clean the receivers. You plot power versus time and you compare it with the beam shape again and again. You catalogue your local noise. You ask what the air traffic was that night. You move slowly toward either an identification or a formal abandonment of the search. Science is not made of fireworks. It is made of this, the long patience that wears uncertainty down until it is honest and modest. Lights dim in the theatre of the mind and the projector shifts, slides. We are back with 3i Atlas and we ask why it matters beyond the headline that it is interstellar. It matters because each such body is a sample of material from an unknown disk around another star. Under microscopes that we do not yet hold in space, the dust would tell us how that disk mixed hot crystals and cold glass, how radiation layered organic films on grain surfaces during long drifts, how pores trapped and then released gases as the grains merged into a small world. Even from Earth, with measurements of color, polarization, and the ratio of common gases, we can begin to sketch the kitchen of origin. Did the material form far beyond the ice line where water forms frost? Did it carry carbon monoxide and carbon dioxide ices typical of very cold neighborhoods? Did it awaken slowly and steadily, like a body that has not been baked by many prior passes near a star? Or did it erupt in spurts like a veteran comet with a crust that cracks along old seams when we place 3I Atlas beside the first visitor ʻOumuamua and the second visitor, the comet discovered by the astronomer Gennady Borisov? A pattern starts to emerge. The family of interstellar visitors is diverse. Some members look like quiet shards. Some look like ordinary comets. 3I Atlas leans gently toward the comet side. The variety is its own lesson. Planetary systems in the galaxy are fertile and noisy places. They throw out shards and snowballs as a normal part of growing worlds. The temptation now is to tie the threads hard and declare an answer to the question that brought you here. Were we warned? The careful answer is quieter and more satisfying. There is no evidence that a civil voice sent a date-stamped note in 1977 to announce an icy visitor in a later year. What we do have are two puzzles that live in the same region of the sky. Puzzles that call to the same human senses. One puzzle is a single minute-long arch in a printout sitting exactly where a wise transmitter might put its tone if it wanted to be noticed by a new species that has just learned to listen. The other is an ice and dust traveler that arrives speaking chemistry rather than code. Also, exactly what nature would produce if small bodies are jostled from foreign nurseries by the gravity of giant planets and are then sent wandering forever. The coincidence is poetic. Science can enjoy poetry and still keep its measurements sharp. Let us linger in that poetic space for a calm moment. Sagittarius is not just a set of stars in a stick figure. It is the direction in which our disk grows thick and luminous. It is where the bulge of the galaxy begins, where radio maps flicker with sources, where hydrogen clouds overlap. The area around the famous Teapot asterism in that constellation holds nebulae like lanterns. In radio-quiet valleys and on dry mountaintops, telescopes dwell there long and often because there is much to hear and much to see. If you placed your ear to the galaxy, you might choose that direction first, not because it is mysterious, but because it is full. When Big Ear heard its minute, long tone, it heard it there. When Atlas traced the path of a moving speck and found the shape of an open orbit, it found it against that rich backdrop. The two events share a frame not in a conspiratorial way, but in a cartographic one. The map of the sky encourages such near neighbors. The outer story now has its pieces on the table: a single radio event, a single comet from away, a shared street on the sky, a present-day inclination to connect dots, and the inner purpose of this slow documentary remains. We want to understand why each piece earns its place in our memory and how to cradle it without crushing it into a forced pattern. When faced with a famous signal, we remember that the hydrogen line is a thoughtful choice for searchers because every technological species that learns radio will learn hydrogen. We remember that narrow bandwidth and beam-shaped windows in the time series increase interest. We also remember that no repetition reduces confidence, and that in science, a single non-repeating event sits in a waiting room until better instruments or better luck call it forward again. When faced with 3i Atlas, we remember that a hyperbolic path is the gold standard for an interstellar origin, and that a visible coma strongly suggests that sunlight is doing the ordinary work of lifting dust. We also remember that each new visitor arrives with its own geometry and schedule, and that the best conclusions are made after many nights. As the room darkens a little more and your breathing slows, you can let the details blur just enough to be soothing. A whisper near the hydrogen note at 1420 megahertz, a pencil line in the margin that says "wow" in a spontaneous hand, a column of time stamps that never found a second arch, a survey camera that saw a dot where no dot had been before, and an orbit fit that opened into the clean curve of a hyperbola. A faint ribbon of dust pointing away from our sun, a gentle, natural answer rising where a sensational one was not needed. 2 stories from the Archer, bound not by secret warning but by the simple fact that the Archer is a busy crossroads. If we are to be warned about anything, perhaps the warning is this, and it is friendly. The universe is not short on wonders. We do not need to exaggerate them to stay awake in awe. The real work is careful listening. It is returning to the same field night after night to see if a tone returns. It is building surveys that do not blink. It is teaching a computer to watch for the little zigzag that means a fast mover is crossing the star field, and then teaching a person to consider whether the fast mover is from the deep outside. It is writing numbers fully and precisely so that a voice can speak them clearly without twin meanings. It is remembering to say hydrogen line with the stress on the first syllable of hydrogen, and megahertz with the stress on the first syllable of mega, so that the ear that hears the story through a synthetic narrator does not stumble. It is the patience to hold a coincidence without forcing it into a pattern that it cannot support, and the imagination to ask open questions kindly. In the years to come, new ears will listen. A giant radio telescope with panels that fill a mountain valley in China will point often toward Sagittarius. A patient array in South Africa and a set of dishes in the American Southwest will form pictures with radio waves that reveal the texture of the galactic center. A new wide field camera in the high desert of the Andes will make a moving map of the sky every few nights, so deep and so broad that faint visitors will seldom sneak by. An infrared sentry in space will look toward the warm glare that blinds ground-based watchers and will see the soft heat of dark bodies that do not reflect light well. And somewhere in the quiet around the second Lagrange point, a small ship may one day wait with its instruments warm, ready to leave its post and greet the next traveler from away. When that happens, no message will be needed. The visitor will speak in gas ratios and in dust grain shapes. Its path will speak of energy and of origin. Its light curve will speak of spin and structure. And if some night a narrowband tone rises again for a minute in the old direction, there will be new receivers to catch it and new protocols to share it instantly with the world. 2 puzzles will remain puzzles until evidence stitches them. And if no stitches appear, we will keep both as separate and beautiful truths. One is a record of a listening moment that honored the most universal note in the score of the cosmos. One is a record of a moving moment that honored the power of careful watching. Some questions are kind when they do not resolve. They remind us that we live inside a living sky. They ease the mind toward rest by replacing the need for final answers with the pleasure of steady attention. In that spirit, we let the archer dim. The whisper from 1977 stays on its sheet of paper, quietly encouraging us to keep the hydrogen line company. The traveler called 3I Atlas continues on its open way, leaving a veil of dust so slight it will disappear into sunlight. And here, in the small gravity well of a quiet room, your thoughts can turn from questions to images. A page with a circle and the word, wow. A tiny comet drawing a pale line through the night. The arch of the Milky Way bending over both scenes with a soft and ancient light. The appearance of the third interstellar guest did not begin with fireworks. It began with a faint point moving just a little faster and a little straighter than ordinary comets do. Night to night, survey images stitch that motion into a curve that refused to close. A careful orbit fit said what the eye already suspected. The path was open, a hyperbola rather than an ellipse, a single visit rather than a long residence. As it brightened, a pale coma gathered around the nucleus and a thin tail leaned away from the sun. On star charts, the track crossed a rich field in the direction of the Archer, the constellation Sagittarius, which is one of the most crowded and luminous neighborhoods in our sky. The association was irresistible, a whisper from Sagittarius decades ago in radio, now an icy visitor against the same backdrop in visible light. The human mind does what it always does. It sketches a line between two dots. To understand what that line can and cannot mean, it helps to place the comet and the sky on the same mental table. Constellations are pictures that we draw on the inside of a great sphere. They are useful labels, not physical places. A traveler that enters our system from a very distant origin carries a velocity vector that points one way in three-dimensional space. Project that vector onto the sky dome and you obtain an apparent direction, a small circle in a labeled region that we call a constellation. If that projection falls near the Archer, we say it seems to come from Sagittarius. The word seems is important. The object did not start its journey in a cluster of stars shaped like a teapot. It began elsewhere, far away, launched by gravitational shoves in a system that may bear no resemblance to our own. The Archer is a map marker, not a birthplace. There is another geometric detail that quietly separates sensation from fact. Astronomers describe an incoming interstellar path in two ways. One is the inbound asymptote, the actual direction from which the object approaches in space before the sun begins to bend the path. The other is the sky plane projection that we draw on charts for observers, a track painted on a two-dimensional dome so that telescopes can follow it. The first belongs to dynamics. The second belongs to charts and headlines. When we say that 3I Atlas arrived against the rich texture of the Archer, we are speaking in the language of charts. When we compute its incoming velocity in the frame of the local swirl of nearby stars, we are speaking in the language of dynamics. Those two languages often point to similar patches of sky, but they are not identical, and they do not tell the same story about origin. The math guides humility. A shared backdrop does not establish a shared cause. The sky itself adds another layer of quiet caution. Sagittarius is large. Its bright stick figure marks only the core of a region that spreads wide along the band of the Milky Way. That band is a highway of hydrogen clouds and star clusters and radio sources. People and instruments linger there because the celestial traffic is dense. A single constellation on the sky can claim many unconnected happenings simply because it holds many degrees of arc. Imagine dividing the full circle of the sky into 12 slices as the ancients did. By simple fraction, there is already nearly a 1 in 12 chance that any unrelated event will carry the same label. The real geometry is more subtle, because constellations vary in size, and because surveys spend more time where the background is rich. Even so, a Bayesian thought experiment calms the pulse. Start with the base rate of unconnected events that happen to share a constellation label. Adjust for the fact that radio astronomers dwell in the inner galactic directions more than in the sparse polar caps. Adjust again for the fact that moving object surveys log many discoveries against that same bright backdrop. The posterior probability that a shared label signals a deep connection falls. With that mental arithmetic in place, we can keep the poetry of coincidence without letting it harden into a claim. Now let the mind step back to the summer night when the famous radio event walked through the beam of a fixed telescope. The printed arch of symbols near the frequency of neutral hydrogen has been examined for decades with patience and with care. Natural and instrumental explanations have been put on the table and turned gently in the light. Begin with an idea that has circulated from time to time. Could a cometary hydrogen cloud have drifted through the beam and produced a narrow tone near the hydrogen line? One can imagine sunlight breaking water vapor into hydrogen atoms that then glow softly at the right frequency. The challenge is that such cometary emission is usually broad and faint, not a narrow and strong spike. It would also tend to last longer than a minute-long drift because a coma stretches over a wide area and would likely light both of the two side-by-side feed horns of that telescope. The celebrated event appeared in only one, with the perfect rise and fall of a point source crossing a single beam. Another natural possibility is the contribution of the complex side lobes of a radio antenna pattern. No antenna is a perfect spotlight. Sensitive petals reach outward far from the main beam, and a strong source might sneak in through those petals in odd ways. If a side lobe was unusually bright at the hydrogen frequency, and if a source crossed it in just the right way, you might see a blip in one channel and not in the next. Yet that scenario must also explain the clean beam-shaped time profile and the narrow band nature of the tone. Side lobe entries often smear and shift in frequency or in time, and they tend to be repeatable when the sky returns to the same field at the same hour of sidereal time. Repeats did not appear. Man-made interference is a third category. Satellite downlinks, aircraft radar, and even terrestrial transmitters can wander into the receiver if shielding and filters are imperfect. This explanation has strength because human technology does use narrow band carriers. It has a weakness because the instrument that night was looking into a portion of the sky where local interference tends to be weaker, and because the event traced exactly the main beam drift envelope. When radio frequency interference sneaks in, it often comes with additional clues. Harmonic companions appear, adjacent channels light up, nearby instruments report the same infection. The historical record offers none of that here. The notebook remains tidy. One arch, then stillness. If one sets those natural and instrumental options on a shelf for a moment, the mind will want to look at a fourth shelf, the shelf with the bold label. Perhaps it was a deliberate transmission from a technical species. If such a species wanted to choose a universal calling channel, it could hardly do better than the hydrogen line. That frequency is written into the structure of atoms. It is the tone that neutral hydrogen sings when the spin of the electron flips relative to the spin of the proton. In numbers, it is 1420.4 megahertz. In poetry, it is the most patient clock tick in the cosmos. There is a second anchor tone nearby. The natural radio line of the hydroxyl radical at 1612 megahertz. The quiet band between the two is known by a charming nickname, the waterhole. A civilization that has learned radio and chemistry is likely to know that metaphor. A narrow tone placed there would be an elegant hello. That does not mean the waterhole hypothesis is enough. The protocols that guide careful listening in the search for other minds have tough standards. A robust candidate should reveal a narrow band carrier and a drift in frequency that matches the expected Doppler shift from the rotation of Earth and the motion of the source. That drift should be coherent and predictable so that a receiver can correct for it and see the tone take a steady seat. The signal should reappear when the telescope returns to the same sky position, and it should be caught by more than one instrument at more than one site to rule out local interference. Where possible, a beam-forming array should confirm that the signal arrives from a far-field direction and not from a nearby source. The famous event passed some of these tests in spirit and failed others in practice. The goal here is not to diminish the romance, it is to put the right frame around it. The tone sits in the waterhole. The time profile matched a sky drift. The event did not repeat. It landed in one beam and not the other. It defied easy natural and instrumental explanations, and it also defied the chain of confirmations that would lift it from legend to detection. Return now to the interstellar comet and the way its path paints a line in our minds. The track seen against Sagittarius is a projection. The incoming direction in the frame of nearby stars is a vector. The two are related and distinct. Sunlight shaped the coma and tail in predictable ways. The tail leaned away from the sun, not toward a radio coordinate. The non-gravitational pushes that appeared in the orbit fits matched gentle outgassing rather than anything exotic. Spectra whispered of water and of carbon dioxide at levels that are patient to confirm and that already feel familiar. It is tempting to tie this clean, natural picture to a mysterious radio event simply because they share a sky label. The better act is to let each stand on its own truth. The radio event is a beautiful, unresolved question that still encourages careful listening near the hydrogen line. The comet is a beautiful, resolved answer that confirms again that other systems throw their small bodies outward and that those bodies wake up gently when they visit a new star. Let us take the probability lens out for a walk just long enough to tame the urge to claim more than the data allow. Imagine the sky divided into a patchwork of unequal regions, the constellations. Imagine a timeline marked by sparse, remarkable events. A single radio tone near a famous frequency in the late 1970s. A handful of interstellar comets arriving in the third decade of the 21st century. What is the chance that two of those sparse points land in regions with the same label? The answer depends on the sizes of the regions, on the attention that observers pay to them, and on the chance geometry that sets where trajectories are projected. The archer holds a larger than average slice of the bright galactic band. Observers aim there more often. Survey cadences are high there. A Bayesian calculation that starts with those base rates will almost always allow a shared label to arise by chance. This is not an argument against curiosity. It is an argument for composure. Within that composure there is a kind of joy. One can still explore the natural options for the radio event with fresh instruments. New receivers can stare for many nights with much finer resolution in frequency and time, correcting in real time for Doppler drift and flagging radio frequency interference with machine learning tools that sift terrestrial patterns. Arrays can form multiple simultaneous beams to watch the same patch with different eyes. Data can be shared openly so that observers across the world can attempt immediate replication. If a whisper returns, the confirmation will be swift. If it does not, the legend remains a legend, graceful and undemanding. One can also keep refining the interstellar comet's portrait without forcing connections. Light curves taken with gentle cadence can separate rotation from activity. Polarization across several scattering angles can tell us whether the dust is made of fragile aggregates or sturdier shards. Thermal measurements can bracket the size of the nucleus even when the coma is thick. Observers can search image archives for pre-covery points that extend the orbital arc backward in time. Each of these adds a firm brushstroke to a canvas that is already legible. The truth is not in doubt. The path is open. The chemistry is ordinary in the best sense of that word. The visitor is a natural page from a book written under a different sun. A final return to the theme of intelligent signaling can be soothing rather than exciting. If someone wanted to place a beacon for young listeners like us, the hydrogen line is sensible and the waterhole is poetic. The signal would likely be narrowband, perhaps modulated slowly to carry a simple message or a prime number sequence. It would be set to drift in a way that an intelligent receiver could predict and correct. It would be repeated like a lighthouse. It might even hop among a few nearby rational frequencies to show intention. Most of all, it would be generous with confirmations. It would let itself be captured by multiple beams, by multiple instruments, by multiple sites, over multiple nights. The world is ready for that. The networks exist. The protocols exist. The patience exists. We do not need to read warnings into coincidences. We can build welcome mats in the spectrum and wait without anxiety. In the meantime, the archer keeps its treasures. The radio maps of that region glow with hydrogen clouds that trace our galaxy's spiral bones. The optical maps pour with star fields so dense that black seems to vanish. The freezer of interstellar space continues to send a rare traveler now and then, and our surveys continue to catch them as dots that refuse to close their loops. Between those scenes sits a kind of contentment. The universe is communicating all the time, not always with intention, but always with meaning. A comet says something truthful about another cradle of worlds simply by sublimating water in our sunlight. A hydrogen cloud says something truthful about cosmic structure simply by whispering at 1420 megahertz. When and if a mind speaks, we will hear it best if we keep our minds settled, our instruments clean, and our standards high. As you let these images dim, a simple outline remains. The third interstellar visitor crossed a rich field and left a thin veil of dust while its hyperbola carried it away. A single minute-long arch on a sheet of paper from a summer night decades ago still encourages ears to linger near the most universal tone in the cosmos. Both happened near the archer on our maps. Neither requires the other to be meaningful. The gift they share is softer. They both teach us how to look and how to listen, and how to rest comfortably with a story that is still being written by patient instruments under a very wide sky. The family of visitors from beyond our sun already tells a calm story about variety. The first one that people noticed was the small and quiet traveler given a Hawaiian name that means a scout who comes from far away. It slipped through our neighborhood in the year 2017. Its brightness rose and fell with a large amplitude, as if the body were greatly elongated or perhaps very flat, and it left no obvious coma even when the sun warmed it. A small, non-gravitational push was measured, which set imaginations alight because there was little dust to see. The second visitor arrived in the year 2019 and looked much more like what our own comets look like. It exhaled dust and gas, its tail glowed in the sun, and its chemistry reminded astronomers of the cold reservoirs that orbit far from our star. The third visitor, the one that sparked this gentle investigation, awakens with a soft coma and a pale tail shaped by sunlight and the solar wind. In other words, two of the three behave like natural comets, and the first behaves like a dry fragment with unusual geometry. What do these three have in common? They all move on open paths. Their orbits are hyperbolic, which means they have more energy than a bound object can have in our system. They all arrive from directions that make sense when compared with the slow circulation of stars in our part of the galaxy. None required a dramatic kick from a planet to explain the speed. They are pieces of other systems, freed long ago and guided by gravity alone. What challenges fantasies is the ordinary way that two of them speak. A coma and a tail are the voice of sunlight on ice. Dust reflects light, and gas carries tiny pushes that we can measure in the orbit fits. Even the first, which kept its gases mostly to itself, can be understood with careful thermal models that allow for slow release of volatiles or for sunlight pressure on a very low density body. That is the style of knowledge that helps the mind rest. Before we invent technological stories, we listen to the simple stories told by dust, light, and heat. When astronomers say that the curve of a comet's brightness is like a heartbeat, they are not being poetic without purpose. The light curve is a diagnostic, a quiet line that rises and falls as the body rotates and as its activity waxes and wanes. If a nucleus is nearly spherical and the coma dominates the light, the curve is smooth and of low amplitude. If the nucleus is elongated and not much dust obscures it, the curve can swing widely and repeat with a clear period. When jets of gas turn on as local morning reaches a vent, the light can brighten a little earlier each day if the rotation and the orbit align. By watching with a steady cadence, observers disentangle rotation from activity. They also learn when a sudden flare is a physical outburst and when it is a processing artifact or a trick of thin clouds. Sensation loves the sudden spike. Physics loves the pattern beneath it. Dust teaches in its own ways. In scattered light, fine grains make the coma look blue and smooth. Coarser grains make it look a bit red and granular. Polarization, the subtle alignment of the electric field of light after scattering, changes with grain size and shape. Fragile clumps of tiny monomers leave a different polarimetric imprint than compact shards. As the comet warms, the dust size distribution can shift. Early far from the sun, gases like carbon monoxide and carbon dioxide lift very small grains. Closer to the sun, water becomes the main driver and can lift larger particles. All this shows up in the light if you watch with patience. It is easy to post a single dramatic image of a tail and claim a surprise. It is harder and better to measure a sequence and say that the distribution of sizes evolved in a way that matches gentle warming. That is how a documentary earns trust at bedtime. It replaces the push of surprise with the pull of understanding. To keep our questions honest, it is useful to place two sky maps side by side. One map is from the late 1970s, when a single minute-long radio event near the hydrogen line was logged on paper. The other is from our present surveys. The coordinate systems are better aligned now. Star catalogues carry precise positions and proper motions. We can roll the old sky forward to the present and roll the present sky backward to the old night and see whether any bright radio sources have drifted into or out of the field. We can reconstruct the beam of the old instrument and ask whether a known source near the edge might have entered through a side lobe. We can overlay satellite ephemerides and aircraft paths to check for the human fingerprints that were hard to trace in the earlier era. This exercise does not require belief. It requires careful cartography and honest bookkeeping. When done, the old result remains what it has always been. It is a strong candidate that did not repeat and did not resolve. The new map is a kindness rather than a verdict. It assures us that we did not miss a plain explanation. It also shows us that the region of the Archer is crowded with natural emitters, which is a fact worth keeping. Sagittarius is a cosmic crossroads because the line of sight toward it slices through the bright lane of our galaxy. Neutral hydrogen clouds fill that lane and whisper at 1420 megahertz. Star-forming regions shine in radio and in infrared. Pulsars tick like patient clocks. The core of the galaxy sits there as a compact radio source, a reminder of a massive object in the center that shapes the orbits of stars in the bulge. Supernova remnants, filaments, and thermal haze contribute to a background that is not quiet. Radio astronomers love this richness because it rewards listening. It also demands discipline because a receiver that stares into that crowd must be well calibrated and well shielded to avoid confusing a stray petal of the antenna pattern for a real voice. When a single tone appears for 1 minute with a clean beam-shaped rise and fall, and never again, it stands out against that busy chorus. The very busyness is part of why the coincidence with a later comet feels poetic. Both events live on the same bright avenue. That makes them neighbors in our maps. It does not make them kin. If such a tone rose today, 3 great ears would be ready to test it in different ways. In a green valley in China, a dish the size of a small town listens to the sky with unmatched raw sensitivity. The 500-meter aperture spherical telescope can spread its focus across the surface and steer it electronically so that a narrow beam can cut through the radio forest and follow a suspect tone as Earth turns. It can also check for a drift in frequency that matches the expected Doppler shift from our rotation and from the motion of the putative source. Drift that follows physics is a good sign. Jitter that follows traffic on a highway is not. In the Karoo landscape of South Africa, the mere KAT radio array combines many dishes to form pictures with radio waves. It can place several beams on the same patch at once, a trick that lets it ask whether the tone arrives from far away on the sky or sneaks in from the side through radio frequency interference. It can measure polarization and time structure. Most of all, it can share data in near real time with other facilities so that someone else can point and verify or refute. An event that repeats even briefly in a predictable way can be triangulated by quick cooperation. On the high desert of New Mexico, the Very Large Array can switch from making images to opening a dynamic spectrum, which is a picture of frequency versus time. In that picture, a genuine tone from space often draws a straight or gently curved line, whose slope is explained by motion. A local transmitter often leaves a barcode, a pattern with harmonics or sidebands or digital encodings that are a giveaway. In a perfect case, 2 arrays on 2 continents and a giant dish in a third country would all see the same tone at the same sky position with the same physics of drift. At that point, the world would know in a single night. The tests are ready because the community built them for exactly this purpose. The new age of listening is not about drama. It is about immediate cross-checks and open data. Even without a new tone, these instruments already test the richer background of the archer. They map the hydrogen clouds that trace spiral arms. They watch the heart of the galaxy with exquisite resolution. They catch flares from magnetized stars and monitor pulsars whose timing rivals atomic clocks. In that sense, the region that hosted a 1-minute wonder long ago is constantly under watch now, and its complexity brings peace rather than anxiety. The more we see and hear there, the less likely we are to be fooled by a petal of an antenna or a passing plane. Between these listening posts and the patient surveys that catch moving dots in visible light, the sky has become a more honest companion. The third interstellar visitor is measured by its open path, its gentle coma, its tail that leans away from our sun. The famous radio moment is measured by its place near the hydrogen line, its neat time profile, and its stubborn lack of a twin night. A documentary for sleep has room for both. The comparisons among the 3 visitors keep us anchored. The lessons from light curves and dust keep us humble. The cartography that rolls the old night forward and the new night back keeps us sane. The crossroads nature of Sagittarius keeps us alert without fear, and the modern ears keep us ready in case a steady voice decides to speak again. Interception changes everything because it changes the pace of learning. Instead of waiting for a traveler to pass and then piecing together its story from a handful of images and spectra, we can be there when it arrives. ready to sample its breath and to sketch its surface while sunlight wakes it. The first clear step toward that new rhythm is a waiting craft. Engineers imagine a small spaceship parked near the second Sun-Earth Lagrange point, a quiet saddle in gravity where a satellite can linger with little fuel. The plan is simple in spirit and subtle in practice. Keep the instruments warm, keep the thrusters and the guidance healthy. Listen for the alert from the watchers on the ground. When a new interstellar candidate is announced with a path that crosses a comfortable corridor in space, the patient ship makes a slow, precise burn and drifts into a crossing route. A mission called Comet Interceptor points the way. It will fly with a larger observatory to its waiting post and then bide its time for years if needed. When a target appears, it will separate into 3 craft. The main body will stay farther out and keep a wide view, recording the overall shape of the coma and the tail and measuring how the solar wind drapes around the new atmosphere. 2 smaller probes will dive closer and trade some safety for detail. Together, the trio will watch from different distances at once, which turns a fleeting flyby into a 3-dimensional movie. Instruments will be simple and sturdy rather than extravagant. A visible and infrared spectrometer to read water, carbon dioxide, and carbon monoxide. A dust sampler with a tiny funnel to catch grains and weigh them, a polarimetric camera to sense the structure of those grains by the way they align light, a magnetometer and a plasma instrument to feel the shock where the wind of the sun meets the infant coma, a thermal mapper to see whether the surface stores heat or sheds it quickly, which speaks of porosity and crust. A different approach trades patience for agility. A craft with ion engines can wander near the second Lagrange point and shape its path gently over months. The engines breathe a faint blue light, trading power for endurance. They are not sprinters, they are long-distance walkers. Given a few months of notice and a favorable geometry, such a ship can slide into a velocity that matches the incoming traveler for a few precious hours. That is enough time to take images that resolve boulders and to taste gas that has not yet mixed with the solar wind. The benefit is enormous. We move from inference to touch, still at a safe distance, but within the cloud itself. Nothing in this architecture needs exotic technology. The exotic part is the discipline. You must launch before the target is known. You must keep the craft healthy without a destination to motivate headlines. You must practice the approach with simulated targets so that the team can fly by muscle memory when the real alert comes. This is a change in culture as much as a change in engineering. It says we are prepared to let the sky set the agenda, and we are patient enough to hold station until the appointment is made. That patience extends to our own storytelling. The word warning appears in the title of this gentle investigation, but the scientific mind hears it as a question rather than a claim. What would count as a warning in the strict sense? If a signal wanted to be read as intention, it would be narrow in frequency and repeated. It would drift in a way that a receiver can calculate from a simple model of rotation and orbital motion. It would reappear when the same patch of sky returns. It would be seen by more than one observatory on more than one continent, and it would live through changes in equipment and software. Ideally, it would give advance notice of a measurable event, such as an exact time when a tone will return or a sequence of simple numbers that carry an obvious structure. The more of these boxes a signal checks, the more the burden of proof shifts from the natural to the deliberate. It is just as important to say what does not count as a warning. A single event that never repeats is interesting and is recorded, but it sits in a waiting room. A coincidence of sky addresses is poetic, but poetry does not carry the load of evidence. A human tendency to connect dots by narrative is not a flaw. It is a gift made for novels, but it must be set aside at the lab bench. The safest method is to ask what the claim predicts and to write the prediction down in plain words before new data arrive. If the prediction fails, the claim is retired with thanks for the excitement it brought. If the prediction survives, the claim earns a seat closer to the center of the table. In this way, we keep the story uncluttered and kind to sleep. We honor wonder without letting it run away with us. Between wonder and patience stands a loud arena where myths are born. Media live by short attention and by sharp edges. Science lives by slow edges and by careful speech. When a strong radio tone appears in an old printout, the simplest headline is a question that leans forward. Were we warned? When a new comet arrives from interstellar space against a grand backdrop, the simplest subtitle is another question that leans forward. Is this the same voice? There is nothing wrong with that lean as long as the fold under it is solid. Problems come when speed strips context. A narrow band tone near the hydrogen line is indeed special, but it must repeat. A comet from away is indeed special, but it must be read in the language of dust and gas before it is drafted into other narratives. Gentle debunking is not the same as mockery. The best way to soften a myth is to give the audience a simple tool that they can use themselves. For radio claims, teach the idea of drift. Ask whether the frequency of the tone changes with time in a way that follows the rotation of Earth and the motion of the source. For comet claims, teach the idea that tails always point away from the sun. Ask whether a dramatic photograph respects that fact. For coincidences of sky address, teach the idea that constellations are labels on a dome and not places in space. Ask whether the apparent alignment has any meaning in 3 dimensions. When people can perform these small spells of reasoning without a gatekeeper, myths burst gently like soap bubbles and leave no residue of resentment. If the old tone did return, or if a cousin of it rose elsewhere near the most universal note in the spectrum, we would know how to listen. The plan begins with triggers and ends with public trust. First, a wideband receiver watches a favored patch, either at the hydrogen line or in the quiet band between the hydrogen line and the hydroxyl line that radio astronomers have long called the waterhole. The hardware records high resolution in time and frequency, so that faint drifts are not lost. The software flags tones that are narrow and that trace a clean path in the dynamic spectrum, that is, in the picture of frequency versus time. Second, an automatic request goes to partner observatories on other longitudes. A dish in Asia, an array in Africa, and a set of antennas in North America point at the same coordinates. The human step here is simply to allow one person at each site to press a single button that grants a short window and begins a capture. The tone should appear at all 3 if it is real and in the sky. If it appears at 1 and not at 2, the flags drop. Third, the data are published within hours, not months. This part matters for public trust. A dynamic spectrum and a short time series of power can be posted in a format that anyone can read. Amateur radio astronomers with modest dishes can attempt to confirm or deny. Best of all, someone else might notice a pattern that the original team missed. Science is a conversation that works best when the doors are open. Fourth, if the tone repeats predictably, a longer campaign begins. Observatories plan cadence and coverage as they would for a pulsar or a variable star. Receivers adjust for drift in real time to keep the tone steady at the detector. Signal experts look for simple structures such as prime number gaps or slow modulations that carry redundancies which show intention. A source that behaves like a beacon would reveal care for our limitations. It would sit in a sensible band, and it would leave footprints that we can follow without guessing. All of this can unfold without high-stakes drama. The tone either behaves like a mindful message or it does not. If it does, the world will learn together because the data will be open and the tests will be simple enough to repeat. If it does not, the world will still be larger for the lesson, and the anecdote will go back to its drawer with a dated and honest note. The same quiet plan holds for the next interstellar comet. Watchers on the ground and in space scan the sky every few nights. A dot refuses to stay where it should, and the orbit fit opens neatly into a hyperbola. An alert goes to infrared telescopes for thermal measurements that bracket the size of the core even when the coma is thick. Polarimetry campaigns begin to weigh the porosity of dust. Spectrographs look for water and for carbon dioxide at the moments when each line rises above the breadth of Earth. The waiting interceptor, if we have been wise enough to place it in space, receives a path and a time. It leaves its post, not with haste, but with grace, and meets the traveler once at a distance that keeps both safe. A trio of craft separates. A narrow-angle camera paints texture. A wide-angle camera paints context. A dust catcher sips grains like snowflakes. A mass spectrometer weighs the gas and whispers numbers that sound like home or like elsewhere. The world watches without losing sleep. The sky is large. We have time. All that remains is to let the two puzzles of the archer find their quiet balance. On one side sits a minute-long arch of characters near a natural radio note. On the other side sits a pale visitor from away who speaks with the ordinary truth of ice and light. Between them stands a person who loves patterns and who also loves proof. The correct posture is a gentle readiness. You can hold the radio event as an invitation to listen better without insisting that it meant more than it can carry. You can hold the comet as a gift from another cradle of worlds without insisting that it is a messenger in any sense beyond geology and chemistry. Where should the next gaze fall? It should fall where patience is rewarded, toward the hydrogen line with receivers that share their raw data quickly, toward the quiet band between hydrogen and hydroxyl, where the idea of a waterhole is as old as radio astronomy itself. Toward the second Sun-Earth Lagrange point, where a small ship can wait for years with its instruments warmed like hands around a cup. Toward the dusty roadways of the Milky Way, where small bodies from other suns are most easily seen against rich star fields. And toward our own habits, which are as important as our instruments. Speak numbers fully so the synthetic voice places stress where it should. Separate story from signal by asking what the claim predicts next. Reward the steady virtue of replication. Remember that a coincidence can be beautiful and also be only a coincidence. In this posture, there is no need to be warned. There is only the pleasure of being awake and attentive in a universe that is full of small surprises. A traveler from far away will come again, and we will be ready with eyes and with a modest ship. A tone may rise near a sacred frequency, and we will be ready with more than one ear and with open logs. If neither happens for a while, we still have the patient tasks of mapping hydrogen clouds, watching dust evolve in comas, and sketching the three-dimensional wind of the sun as it wraps new atmospheres. The archer will keep its lights, we will keep our calm, and the space between science and story will remain a soft and generous place where a person can fall asleep with a sky in mind and a quiet confidence in how the morning will measure it. The final chapter in our quiet journey looks outward across the opening decades of the 21st century and gathers the discoveries that changed how we think about the cosmos. Rather than a list of trophies, imagine a gallery where each frame is dimly lit and restful, inviting you to linger. Every picture is a door to a calmer understanding of where we are and how the universe behaves. The numbers, the dates, and the names arrive softly, as if carried by the breath of space itself. Begin with worlds around other suns. At the turn of the century, planets beyond our system were rare announcements, each one a surprise. Then a patient experiment called Kepler began to stare at a single patch of sky and count the tiny dips in starlight as planets passed across their stars. Over the span from the year 2009 to the year 2018, that spacecraft revealed thousands of worlds. From those small eclipses, we learned that planets are common, not occasional. Super-Earths, which are rocky worlds larger than our own, are abundant, even though our system does not contain one. Mini-Neptunes, with thick envelopes of gas, orbit closer to their stars than we once thought possible. The idea that each star might host its own small family changed from wish to expectation. Soon after, a new wide survey began to sweep the nearer sky. The transiting exoplanet survey satellite, whose long name many people shorten in conversation, found planets around bright nearby stars that are easier to study in detail. One small system called TRAPPIST-1 offered 7 rocky worlds in a compact chain, all circling a quiet red star. Another discovery placed a temperate planet around Proxima Centauri, the nearest star to the Sun. These finds shifted the question from whether there are other worlds to which of them we can read closely. Reading closely has become its own art. Telescopes in space and on the ground learned to tease out the faint signature of gases in an exoplanet atmosphere as starlight filters through the thin rim during a transit. Early in the decade of the 20s, the James Webb Space Telescope began to measure water vapor, carbon dioxide, methane, and clouds on worlds that are many light years away. The precision is already enough to see how sunlight shapes chemistry and how clouds form and break. For now, we study warm giants and hot rocky planets because they speak the loudest. The technique grows calmer and more sensitive each year. The promise is not a distant dream. It is the quiet climb toward reading the air of worlds that are more like home. Another frame in the gallery holds a picture from the heart of gravity. In the month of September of the year 2015, an instrument measured a ripple in space-time itself from the merger of 2 black holes. more than 1 billion light-years away. The Laser Interferometer Gravitational Wave Observatory caught the tiny stretch and squeeze of a passing wave with mirrors so still that the change in distance was smaller than the width of a proton. In human words, mirrors on Earth felt the faint echo of a violent event across the universe. A little more than 2 years later, the same kind of instrument heard the coalescence of 2 neutron stars. The exact time and place on the sky were shared within minutes, and telescopes across the world and above it turned to watch a new kind of fire called a kilonova. In that single event, light and gravity and particles told a single story. Heavy elements such as gold and platinum were forged in the neutron-rich debris and scattered into space. 100 years earlier, a person described gravity with a new geometry. In this century, we heard that geometry sing. If gravity ripples were a music newly audible, the edges of darkness were images newly visible. In the year 2019, a network of radio dishes that stretched across the Earth made a picture of a black hole in a galaxy named Messier 87. The image was a ring of light with a dark interior. The ring is light bent by intense gravity. The void is a shadow cast by a region from which light cannot escape. In the year 2022, the same collaboration released the first image of the black hole at the center of our own Milky Way. The radio glow is a little blurred because gas swirls fast around a smaller central mass, but the shadow ring is there, softly outlined by matter near the point of no return. For the first time, black holes left the realm of pure inference and entered the realm of portrait. Between gravity and images lives a third kind of messenger that came into its own during these decades. High-energy neutrinos, ghostly particles that pass through matter almost without a trace, were caught in the ice of Antarctica by a patient array called IceCube. In one case, a neutrino was traced back to a flaring galaxy with a bright jet. That single match connected an invisible particle to a visible source and opened a long future of neutrino astronomy. The lesson is soothing. When many kinds of messengers are heard together, the picture grows deep without growing loud. Closer to home, our own neighborhood changed as if a light had been turned on. A spacecraft named Gaia began to measure the positions and motions of more than 1 billion stars with exquisite precision. Over the course of a few years, the map of our part of the Milky Way changed from a sketch to a living flow. We saw how streams of stars are the fossil remains of long-ago mergers. We saw how the disk of our galaxy ripples. We saw how the sun moves among neighbors. The sky became a slow river rather than a mural. Meanwhile, the oldest light became a crisp guide. The maps of the cosmic microwave background made by satellites at the start of the century and in the next decade showed tiny ripples in temperature across the entire sky. Those ripples are the seed patterns of everything. From their sizes and heights, cosmologists read the age of the universe, the relative densities of normal matter, dark matter, and dark energy, and the geometry of space. The phrase precision cosmology became a calm truth. Later surveys used the spacing of galaxies and clusters as a standard ruler called the Baryon acoustic scale. Together, these measurements assembled a story that fits with many lines of evidence. The universe is expanding. The expansion is accelerating. An unknown component that we call dark energy drives that acceleration. The numbers do not shout. They line up. Some discoveries carry the sharp smell of the sea. In the year 2005, a spacecraft watched fountains erupt from the south pole of a small moon of Saturn called Enceladus. Those jets of vapor and ice grains hinted at a warm ocean sealed under the crust. In later flybys, the spacecraft tasted salts and organic molecules in the spray and measured the heat coming from long fractures called tiger stripes. A little farther outward in the solar system, another ocean likely lies beneath the ice of Europa, a moon of Jupiter, where tidal flexing the size of continents keeps water liquid. The idea that warm oceans may be common beneath cold shells is one of the century's gentler revolutions. Life as chemistry and time may have more rooms to inhabit than we had imagined. Water turned up in dry, seeming places as well. In the late years of the first decade, a lunar orbiter and an intentional impact experiment found signs of water and hydroxyl in the polar shadows of the moon. Later, observations from an airborne telescope detected water in sunlit lunar soil. The quantities are small, but the presence is steady. On Mars, rovers found ancient lake beds with clay minerals, rounded pebbles shaped by flowing water, and organics preserved in rocks. A later rover began to cache samples for a future return to laboratories on Earth. The red planet speaks with layered rock, not with grand gestures, and its words say that it once had conditions friendly to the chemistry of life. Pluto, once a tiny dot with a simple label, became a world with a heart of bright nitrogen ice, blue hazes stacked in the sky, mountains of hard water ice, and plains that churn slowly like a frozen sea. A flyby in the year 2015 revealed a landscape textured like a dream. Farther inward, a small impactor struck a moon of an asteroid called Didymos to test whether a human-made object could shift a small orbit. The deflection was measured and confirmed. Planetary defense moved from story to first proof. Comets and asteroids gave gifts straight into our hands. A European spacecraft chased a comet for years, orbited it, and even placed a small lander on its surface. The pictures of cliffs and hummocks and the measurements of dust and gas rewrote comet physics in a tender key. A Japanese mission visited 2 near-Earth asteroids and returned grains of carbon-rich material. Those grains contained amino acids, complex organics, and minerals that had once been altered by water. An American mission delivered a sample from a dark asteroid named Bennu, full of hydrated minerals and carbon compounds that tell a slow story about the earliest solids in our system. The laboratory becomes a telescope when the sample sits beneath a microscope lens. In the deep sky, a new kind of radio flare stepped into view. Fast radio bursts, millisecond flashes from far galaxies, were first noticed in archival data and then pursued with coordinated campaigns. Some repeat, some do not. At least one in our own Milky Way has been traced to a magnetar, a highly magnetized neutron star, linking a rare kind of starquake to these bursts. The riddle remains warm rather than hot. The feeling is that we are learning the grammar of a new phenomenon. 2 visitors from other suns crossed our space and left inscriptions. In the year 2017, a small object passed by on a swift, open path. It was too dry to form a clear coma and too oddly shaped to fit easy expectations. Its small extra acceleration puzzled observers and inspired creative models of how light pressure can push on a thin or porous body. In the year 2019, a true comet with a visible coma and a dust tail swung through on a similar open path. It looked like a relative of our own long-period comets, only born under another star. Together, they told us that the spaces between systems are not empty of small things. Strays wander, and sometimes we meet them. Beyond the heliosphere, two hard-working spacecraft from the late 20th century slipped into the local space between stars. One crossed the boundary in the year 2012, the other in the year 2018. Their simple instruments felt the change in plasma density and the shift in magnetic field direction. The transition from the solar wind to the wider breadth of the galaxy was not a wall but a river mouth. That feeling of stepping beyond is quiet and rare. The data streams are thin, but each number is a line in a poem about leaving home gently. A softer but vital transformation happened in how quickly the sky shares what it knows. When a supernova is seen in a nearby galaxy, astronomers now place notices where anyone can read them within minutes. When a gravitational wave is detected, a region of the sky and a time window are shared with hundreds of teams at once. When a comet is discovered, its orbit is posted and refined almost in real time. The effect is not dramatic, but it is profound. Science has learned to speak in a chorus, and discoveries mature faster without losing care. The James Webb Space Telescope deserves a second and quiet mention because it opened new rooms on many floors. It looked at galaxies whose light has traveled for more than 13 billion years and saw them as compact, bright knots at a time when the universe was still young. It observed star-forming regions and traced how ice mantles on dust grains carry simple chemicals into the disks that will build planets. It read the atmospheres of hot exoplanets and drew maps of clouds in worlds that would boil lead. None of these were impossible before, but all of them gained depth and palette. A telescope is a kind of language, and a new one adds words that we did not know we needed. If you step back from the gallery, a larger pattern emerges that is as calming as it is rich. The early years of this century made the universe measurable in many coordinated ways. A mirror on the ground catches a passing gravitational wave, while an array of antennas catches a gamma-ray burst, and a set of small telescopes catches a fading afterglow. A space telescope reads carbon dioxide on a planet around a star that also lives in Gaia's map, with its age and motion known. A laboratory measures an amino acid in a grain from an asteroid, while a rover on Mars watches dust devils dance across a dry lake bed. The many instruments do not compete, they braid. From all of these threads, a simple truth remains that is friendly to sleep. We live in a century where the cosmos became familiar without becoming dull. The great themes are continuity rather than rupture. Planets are plentiful. Black holes can be imaged and can sing. Oceans may be common under ice. The early universe is bright with small, fast-growing galaxies. Heavy elements are minted in cosmic forges when stars collide. Small bodies carry the memory of water and carbon and patience. The nearby galaxy is a river of stars whose currents we can now watch. The sky is less a panorama and more a process. There are open questions that we hold lightly. The precise nature of dark energy remains unknown. The expansion rate measured from the early universe and the expansion rate measured from the nearby universe differ by a small margin that may point to new physics or may relax as methods refine. The first promising hints of biosignature chemistry in an exoplanet atmosphere will need careful confirmation and then independent replication. The map of the Milky Way will reveal more streams and quieter mergers in the data to come. These are not worries. They are spaces left on the wall for new frames. If you wished to choose a few moments to keep as small stones in a pocket, you might choose these. The first whisper of gravitational waves from a black hole merger in the year 2015 and the luminous kilonova 2 years after. The ring of light around the dark heart of a galaxy in the year 2019 and the ring at our own center in the year 2022. The first rich harvest of exoplanet atmospheres, whispering molecules in the early years of the 2020s. The blue jets of Enceladus that told of an ocean and the blue haze of Pluto that told of a sky. The gentle deflection of a small moonlet by a tiny impactor to show that safety can be tested with care. The return of dust grains that carry amino acids and hydrated minerals to laboratories where students hold prehistory in a vial. The long, low hum of hydrogen etched across the sky that still guides cosmology like a sextant. The century is not yet old, and its discoveries are not exhausted. Even if the pace slows in your thoughts as sleep approaches, the work continues in the patient cadence of instruments that never tire. A radio array keeps its vigil in a quiet desert. A mirror in space stares past the warmth of our air and sees the cold light beyond. A small ship waits with its instruments warm near a balance point in the Earth-Sun system, ready to leave if a stranger calls by. A rover on a red plane works through the morning frost and drills a few centimeters into a stone that remembers water. None of this makes a noise in your room. It is the kind of science that respects the night. When morning comes, the gallery will still be there. You can walk again past the exoplanet wall and remember that planets are many. You can pause again at the gravity room and think of space and time as a flexible cloth. You can stand again before the ocean worlds and recall that warm salt water may be a common story beneath cold surfaces. You can read again the small labels under the frames where numbers are written in words and years are spelled out like lullabies. And if a new frame has appeared overnight, perhaps a spectrum of a cooler, smaller world, or a map of winds on a planet that never shows its dayside to its star, you will know that the 21st century did not happen all at once. It unfolds like a quiet tide, carrying pieces of understanding onto the shore where we live.